Testing. Hello. Hello, 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 hello. Nothing still. Hi. My name is. Whoa. There we go. Are we good? Yes. Thank you very much. Yes. Testing. Oh, is that right? If they can just. Oh, it's outside. I see. Is that okay? Hello, 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 hello. Yeah. Okay. All right. I think we're good. Start us off.
I guess we'll start then. Hi everyone, welcome to Vancouver, or at least those of you that actually are here. This is PIM at IETF 120. So I've been told that we should give you enough time to actually read the note well, more or less. So yeah, please have a look at the note well slide here. Hope you all are familiar with it. So these are some important policies that we should all know about. So this is the agenda. Any comments on this? It's a much shorter agenda this time for some reason than what we had the last couple of meetings.
David Lamparter. I'm not sure if it's part of the agenda. I do want to point out the router alert discussion that is happening on the mailing list. I don't think it needs to be discussed here, and there's probably nothing to be done about it. But if you're not aware of it, there is some MLD versus router alert deprecation thing.
Yeah,
maybe read the email and that's it.
Yeah, I'll mention it briefly soon. Yeah. Okay. Thanks. So I'll do a little status update of the different working group drafts. So we have this BIS documents for IGMP version 2, sorry, V3 and MLD version 2 and IANA requirements. So these are all, they have all gone to the ISG. We're hoping those will move forward easily. One thing here is with MLDV2, as was just mentioned. In MLDV2, we are using router alert, and there's some discussion about deprecating router alert. So some people potentially want to, maybe remove router alert from MLDV2 BIS, but people may have different opinions about that. But one thing I feel strongly about is at least that, it would be bad to have a BIS like progressing to internet standard if existing implementations would not be compliant. So, but yeah, I'm sure there will be some discussion about this, and we will hear what ISG is saying, and there's some emails on the mailing list as well. We're also revising the what is it called, host stack requirements for multicast or whatever it's called. Torles will talk about that later. So we haven't requested publication on that yet, and we haven't done the last call yet either, but we'll see how that progresses. But yeah, the main thing with that is really to mention IPv6 and also SSM. Those things didn't exist when RFC 1112 was written. Okay, we have some DR related drafts. We should figure out, do we actually want to work on those things in the working group, and if we do, what should be the path forward?
Is Makamana here this week?
No.
Okay.
No, he's not. Otherwise, we have a bunch of documents we requested publication for. So not just the BIS documents on the previous slide, but also point-to-point policy. The policy ping has passed last call, so we'll request publication for that shortly. like this week or so. PIM Lite requested publication, Lisp extensions as well, and the MOFRR draft also. So lots of documents leaving the working group. Of course, there's always a chance that ISG or someone will come back and we will have to do some more work on some of them, but hopefully not. And some Yang models that are not being discussed today. Lessons learned is on the agenda. And finally, we have some documents related to ZeroConf, and one of them will be presented and discussed today. All right, any comments on this, any questions? Yeah, I think we'll move on to the first presentation then.
Yeah, Hitoshi.
Yeah.
Okay, hello everyone. So this is a new working group draft. Thank you for your support. And of course, with Luis Telefonica. Next, please.
Yeah, sorry, can I just make one comment? So I see what I forgot to add to the working group slides is that, yeah, we just adopted this document and we also adopted this PFM extensions document. So I should have put those on the slides, but okay, sorry, go on.
Okay, thank you very much. So this background the page I already mentioned in a previous meeting. So we definitely need to support multiple upstream interface, so-called merge forming or merge pass supported by MLD IGMP proxy. Okay, next please. So the overview of this draft is we propose an extension that allows IGMP embedded proxy devices to receive multicast sessions or channels through the different upstream interface. Of course, the downstream interface, we have receivers, multiple receivers. So only the extension allows to add the functionality to support multiple upstream interface. But so-called we now, it's merge forming. So the intended status is informational because there is no protocol message extension in this draft, but actually our different draft that will include some functionality to change the dynamic configuration based on some condition, which upstream interface is good for the current status and so on. So that kind of protocol extension will be happen later, but this draft itself doesn't provide any protocol or message extension. So that's why intended status is informational. So we have two major main sections. One is upstream interface selection and the other is upstream interface configuration. So upstream interface selection, we have two methods, subscriber-based upstream interface selection and channel-based upstream interface selection. Either selection mechanisms can be configured with two main configurations. One is address prefix record, the other is interface priority. Interface priority enables to select either interface takeover or robust data reception. I will talk about them later. So, and this draft introduces dynamic upstream interface configuration, as I mentioned earlier, but just this introduced the signaling-based upstream interface configuration like IGMP MLD protocol extension, and also provide SDN-like control-based upstream interface configuration. But again, this is just an introduction, so the detailed specification may be in a separate draft. Next, please. So this is the upstream interface selection mechanism. So we have two ways to select the upstream interface. One is a subscriber-based upstream interface. One or multiple upstream interfaces is selected from candidate upstream interfaces based on subscriber address prefix. And the other is a channel-based upstream interface selection. One or multiple upstream interfaces is selected from candidate upstream interface based on channel or session ID. and the source address prefix is prioritized. So both subscriber-based and channel-based upstream interface selections can be coexisted. However, subscriber-based upstream interface selection is prioritized. So, and also we can use a default upstream interface if there is no configuration or long configuration. Next, please. So how we can configure such kind of upstream interfaces? The entry of the address prefix record consists of subscriber address prefix and channel or session ID, where channel session ID is the source address prefix and multicast address prefix. So as an example, I can show here that the possible combinations by interface can be receiver address or prefix S and G, receiver S star, receiver star G, star SG, star S star, star star G, and or star. So this is a prioritized order. So and the interface priority also can be specified or configured for interface takeover, which means that one interface is usually activated and the other is in a standby mode. But if something happens, then the address upstream interface takeover happens. So in that case, maybe the other prefix record has so several or multiple interfaces have the same address prefix record, but the priority values should be different. So the one interface is usually active, the other is standby. And if we have all the same address prefix record configuration and the priority values, then we can use both. This calls robust data reception. So use multiple interfaces if both address prefix record and the interface priority are identical. In that case, the proxy device itself can send a join or subscribe message to multiple upstream multiple upstream interface via multiple upstream interface. Then the same content comes from both, and the proxy device can select which should be forwarded to downstream receivers. Next, please. So we have one potential misconfiguration. So for the subscriber-based upstream selection, this happens mainly when we have a shared link for the downstream receivers. So upstream interface selection per subscriber receiver aims to differentiate receivers based on their contract or other matters or considerations. However, so look at this figure, the left-hand figure. So this is maybe something like a regular case. So some provider wants to distinguish the receiver, in this figure, receiver 1, receiver 2. So the proxy devices, this proxy device configure receiver 1 is prioritized because of some contract. So his join message is sent toward the red cloud via interface 1, and the interface 1 may have a higher bandwidth, and the receiver 2 may have some, let's say something like a free contract, and then his interest message sent to interface via interface 2. So this kind of business model happen, but if these receivers are on a shared link, even though receiver one's join message is sent toward the interface 1, the contents coming from interface 1 can be shared with the receiver 2. So this, of course, happens if the downstream link is shared. So that kind of a scenario we need to clarify, but well, this happens in several cases. Next, please. So the next step is we definitely need to define the default active interval to detect an inactive upstream interface for interface takeover, because currently what time is the best time for detect the activate or inactive interfaces. So currently there is no definition, so we will carefully consider some time when sorry.
Oh, is that on?
Yeah.
Yeah.
Okay. Coming back. So this kind of timing we should definitely define as, of course, guideline. It should be tuned. So it should be tuned. And we also need to consider interaction with signaling methods. We have been also working or thinking about protocol extension, how dynamically select the best upstream interface using IGMP MLD protocol extension. And also we need to request updating IGMP MLD proxy Young model, but this comes after maybe publication. Okay, that's all for today. Thank you.
David Lamparter. I'm not quite sure I don't understand how this works if subscribers have more than one prefix. Is that a concern here?
Subscriber, so receiver has
Yes. If they have more than one prefix assigned to them for unicast, like if the address, how do you need that for identification? I'm not sure I completely understand what the interactions here are.
Maybe I cannot catch your point, but anyway, so receiver, so the proxy device can configure, so categorize or distinguish the receiver. Some receiver is a paid customer, some receiver is not a paid customer. So in that case, we can configure this paid customer should be prioritized. So if we have multiple upstream interface, the first one is, for example, higher bandwidth, and the second one is lower bandwidth. So we can categorize based on such kind of contract. So it's not, well, this is an aim for defining such kind of a receiver address prefix. Thank you. Any question?
Yeah, one question. I don't remember now, but do you have any discussion about using unicast routing to decide on a prefix? Like for SSM, you could choose potentially upstream interface based on what has the best unicast route.
What do you mean that the unicast route? So a proxy device has a unicast route to the
yeah. Let's say the proxy has like a unicast routing table, and so it knows that for certain unicast prefixes, interface one is the best, and some other prefixes some other interface, right?
Toward S.
Yeah.
You're asking toward S.
Yeah.
Okay. So there is no consideration about toward S. So this is just a configuration for the receiver side. So if you have some best path toward S, then usually, okay. So this kind of scenario must be mentioned in this draft.
Yeah, just a thought. I think it might be useful. So I think what you are defining so far is maybe more like a static configuration that certain flows should go a certain interface. Well, if you use the routing table, it can be more dynamic. But I know the problem is, of course, that you may have many interfaces, and what is best for unicast may not be best for multicast. But
okay.
But I think it could be useful.
Okay, I understand. Okay.
Yeah.
Thank you. Yeah. Okay, we'll consider it.
Yeah. I guess one other thing too is potentially with embedded RP. You know, if you have an embedded RP group, you can see what is the RP address and which interface has the best route towards the RP.
Okay,
potentially.
I see. Okay, I see.
So I think some of these things were discussed on the mailing list recently, where someone was asking about host behavior when someone joins. When there's an MLD join on a host, and the host has to decide the interface. And I think the same can apply to a proxy.
Okay, got it. Okay. Okay, thank you. Yeah, I will consider it. Thank you.
Thank you.
Okay, thank you.
Okay. Yeah, hi, I'm Stig Venas. I'm going to present this draft on PFM enhancements. So I've been the last couple of IETFs have been presenting two different drafts related to PFM. And at the last meeting, there was a suggestion to merge the two drafts into one. And we have done that. And the merged draft just got adopted a few weeks ago, a few days ago. Yeah, next slide. So the two drafts that got merged into this one is about forwarding enhancements. I'll talk a little bit more about that, but I have presented that in previous meetings as well. And the other one was defining sub-TLVs. The sub-TLV draft also had like one specific sub-TLV on bandwidth, but as suggested, we have removed that for now. So it doesn't actually define any sub-TLVs, it just introduces the sub-TLV concept. Okay, next slide. Right, so for the sub-TLV, the idea is that you already have a TLV for announcing an S, G. But if you want to have any kind of additional information about an S, G, there's no easy way to kind of say which of the S, Gs in a message this applies to. The most natural way, or pretty much the only way I can think of, is to allow for sub-TLVs, so that you have a TLV that defines an S, G, and that TLV can have sub-TLVs that can have any kind of information that we think is useful for a particular flow. Next slide, please. So here is how it's defined today, with basically just S, Gs or a group and then a list of sources. Kind of like the PIM joint format. Next slide. And the new TLV that I'm proposing is basically, I simplified a little bit here with just the group and a source, not a list of sources. And then you can have sub-TLVs that can have various properties about this particular flow. Yeah, bandwidth could be one, but there can be, there's a lot of possibilities here. Yeah, I don't have a list of sources here, partly because I think it's unlikely that you have the exact same additional flow information for multiple sources, and also just to make it simpler to parse. The downside is that you are using a little bit more space in the packets if you have many sources for the same group, as you have to repeat the group address. Next slide. And then the other part of this combined document is the flooding optimization. And the basic idea is we have an existing RFC where you can announce a router ID in PIM hellos. And we can use that so that if we have multiple links between two routers, like we see in this diagram here with 3 links, we can actually know that the routers sending PIM hellos on each of those 3 links are actually the same router. So there's no reason to announce the same information to that router 3 times. So the simple idea is, if you have this case, let's just send it once on one of those links. The only problem is that normally the receiving router does RPF check and would only accept it on one of the links, and we don't know which one. So another part of this optimization is that you do a relaxed RPF check. So you do an RPF check, you find one of these interfaces, you check what's my neighbor on that interface, it's router A. And then you say, okay, in that case, I'll accept this message from router A regardless of what interface it comes on. You just trust that router A is not going to send it multiple times. Okay, next slide. I think this is pretty much explaining what I just said. So that's all I have for now. It's more or less repeating what I presented before. We're looking into doing a prototype of this, just to see that things are working well in practice. If anyone has ideas for, any comments on this, things we should do differently, or ideas for how this can be useful, like the sub TLVs, please get in touch. Bring it up on the mailing list. Okay, thanks. Okay.
This is Dino. In your diagram with the 3 interfaces, could you send joins over all of 3 of them for like in a MOFRR type mentality?
Yeah.
Or you're not suggesting?
But you can send joins on all of them. So you can say this announcement, you should only receive it once, ideally, not
Yeah.
like on each, but you can still send joins on any link that you.
And the upstream router knows only to forward on one.
No, you will actually, you can say this is just for learning about the source. The
Yeah.
actual join can be sent on any interface. We're not changing the logic.
Oh,
for
okay. That's what I was wondering about that part.
Right.
Okay.
So you could say for MOFRR, right, you want to use a hash for something, or I mean, even general PIM, you want to use a hash to spread it out, and that's the same as before. One thing I guess I've been wondering is whether it's useful to do this for BSR or if it's not just worth it, but it could easily be done for BSR if we think it's good. Okay, yeah, thanks. Huh? Oh yeah, it's yours. Yeah, yeah, we're ahead of schedule, I guess.
That's small font. So this is the draft we've been working on for some time now. We update it before every IETF with some new topic, just to describe a variety of protocols used over the years, why we maybe no longer use them, and in some cases why we still do. It's already proved useful for me. I had someone reach out to me recently, a pretty famous engineer that you all know, who is a professor, and they wanted to just know what the latest is with protocols, multicast protocols. And so I just forwarded this draft to him just to kind of give an update of what's been going on, and it proved helpful. So this is the one in red is the one we added just recently. It was suggested by Itoshi last IETF, and that is just group address allocation. So we added a little 2-paragraph section on that topic. Next slide. So that didn't format very well, but this is just the text from that. We just go over just really briefly some of the previous approaches to multicast group allocation, dynamic multicast group allocation. There used to be a working group called MALIC, multicast address allocation, which I don't remember very well, but some of you probably do. So we may be able to include some more information about that, but that's where MADCAP was specified, along with some others. And so we just go over that a little bit. And then I get into next slide, maybe the next couple slides.
Yeah, next slide.
Next slide.
Yeah.
Yeah. So then we just go over something that Nate recently revived in the last year, and that is just some new ways that we can do this dynamically without any configuration in a decentralized way. And so we've come up with a couple solutions, zero comp and gap, which has been presented several times, and just kind of go over that those solutions a little bit. And then next steps are, we were just focusing on major issues and lessons learned, and didn't plan to include all protocols, but Greg actually mentioned in a couple meetings ago that it would be good just to include them all. So we agreed just to cover everything that we can come up with. So this will be something that we'll be working on for quite some time, but we are making steady progress. Thanks again to Hitoshi. He mentioned the last one. The next one that we think we could probably come up with is reliable PIM, like include port, reliable multicast in general. So that's something that we'll add. Greg.
Yeah, I haven't read that section, but I don't remember, is SDP mentioned anywhere?
Yeah, it is. There's a section on
Is it in the address allocation, or is it just?
On its own.
Interesting. Okay.
Yeah.
It's part of the story.
Yeah, it is. And we could, I'm sure, expand upon it. And that's another good point. You mentioned story. That's kind of what we're trying to do, is just try to create a story of the history of multicast, and it seems helpful so far. Any questions or suggestions on other topics going forward besides what I already mentioned?
Hello?
Yes.
Yeah, so I think to go along with similar to what Greg said, I think the new section is good, but it's a part of the story of addressing. I think it would be good to tell the whole story of addressing from, you know, the ad hoc list, the ad hoc block that SDR used to GLOP. It'd be great to know where GLOP comes from, because it's not even an acronym. I've always wondered that. There's the
I do. Got the
unicast-based
story.
unicast-based multicast prefix stuff. You know, the 234/8 stuff. There's and then also talk about SSM, how SSM in many ways made it all moot. It solved the addressing problem, at least for SSM. So I think you know, a broader story of addressing in general would be good, where this fits in. And I think in the text you cover MADCAP briefly, but I think it would be worth covering also you know, MASC and MDNS, and you know, that malloc stuff was a little bit ahead of my time as well. I was just starting when those things were happening. So along with Greg's spirit of let's talk about everything, I think we should talk about MASC and malloc.
So to that point, Lenny, that this story I have written, I'm still writing. I still have a bit. I in my version, I don't have this text. That's all 4, and section 3 is the narrative that references each one of those. As for GLOP, that was Peter Lothberg came up with the idea, fed it to Meyer. We went to coffee that morning, and he liked GLOP as a name and asked us to find a way to make the acronym work. And we never did, and that's how the IETF works.
Yeah. Okay. Thank you. Yeah. So to Lenny's point and Greg's, maybe we should have a section just on addressing in general with some sub points related to that. So maybe we'll figure out how to format that and include those.
And failed acronyms.
Yeah, and failed acronyms. Okay. Thank you. All right. All right, Nate, you're up.
All right, can you see me okay?
Let me pull up your presentation.
I've got a demo I can run actually too, so I could run the slides here, or we could give it a try.
Whatever you prefer.
See, I tried. I tried sharing. Okay, here we go. Assuming you can see that.
Yeah.
Okay, great. All right, so these are updates. Sorry?
Can you go into slideshow to make it bigger?
Sure.
Yeah. Kind of.
There we go.
Yeah. Perfect.
Okay. All right. So primarily today, rather than discussing the documents, we've done that mostly in the previous meetings. Just going to discuss some recent discoveries and some updates that I made to account for those. So just a reminder, there's a proof of concept out on GitHub, and then just kind of an update. We're working now on a more extensive proof of concept that will have actual application data, so we can experiment with things like what happens when a collision occurs and what the actual effect to the user will be on that. So the issue that I discovered recently is that
In the past, what we've been focusing primarily on is collisions where two different hosts are allocating the same, not necessarily IP address, but by the time it gets translated into an Ethernet address, it becomes the same Ethernet address. So how do you resolve collisions at the Ethernet level with that? There's another type of collision that is actually more related to the internal hardware of the switch. So up here, I reference a US patent that talks about a switch that, and some of the behavior that would occur in a switch, but basically that the switch will have a big addressing table, which is a hash table. And when it's trying to look up what to do with a given Ethernet frame, it'll look up, it'll calculate a hash of its destination MAC address and use that to locate an entry in the table. And then when you go into that entry in the table, what's commonly how hash tables are implemented is you would have maybe a linked list after that. But with this particular switch, it uses buckets instead. So the example I've got on the screen here is a switch that has 4 buckets for each entry in the hash table. So when it's looking at the destination MAC, it calculates the hash, goes to that location in the hash table, and then finds the entry that corresponds with that MAC address. Now, if all 4 entries in that table are full, then there's no room for additional addresses. So in this case, you might have 3 unicast addresses and add a multicast, or you might have 2 multicast addresses and 2 unicast. In either case, there's no room for additional addresses. And if you go to add a new unicast, for example, that could potentially be problematic as far as being able to communicate with that device. So the patent talks about things like aging entries and stuff like that, but want to try to account for that in the allocation protocol. So just a reminder how the zero-conf algorithm works is it uses NDNS and it creates a PTR record, a unique PTR record that reflects the layer 2 address for the allocated IPv6 address. It uses the probing algorithm to query for that PTR record. And if the probing algorithm completes without a conflict, then the application begins advertising that PTR record. And that's kind of like saying, I've allocated this address. Now, the content of the PTR record is kind of a mix of the host name and the application. We include an application there so that the same host can allocate multiple addresses for it. Now, this allocation is meant to really only happen the first time the network powers up or a new application joins the network. And that's accomplished by retaining that group ID that's randomly generated. So you save that in long-term storage, you start up, you kind of make an assumption that you have that available and you start with that. You still do the probing, but there will no longer be a need to, there would no longer be any conflicts associated with that. So those conflicts would not be repeated. So what was added in the newest version that I posted last night to the zero-conf file, so to the problem statement, it kind of gives a general description of these types of collisions, and then to the zero-conf algorithm, it adds what's called a veto record. And again, this is a unique PTR record. It's got the same generated string as the address, but in this case, it's published without probing, so that it kind of takes precedence, and it also forces a conflict. And that conflict would override the address that's been allocated by one of the hosts already. Now, the PTR name, DNAME for that is the string veto. And basically that would kind of override what the application has allocated. But basically the application would respond the same as a collision. It would allocate a new ID. It would retain that new ID. And so that same conflict is not repeated in the future. So along those lines, I want to try to pull up a demo here, just what that looks like for the proof of concept that we have out on GitHub. Okay, so that's the demo, and that's basically what I had to discuss. Are there any comments on that or questions?
David Farmer.
The so you're using link local multicast DNS. Can it also use the DNSSD gateways to an actual DNS, or do all the things have to be on the same link local? Does that
Sure.
make
So,
sense?
yeah, the document kind of talks about that a little bit in that it's primarily meant to be for the local network, but that it could be extended into other subnets, based on incorporating other things like those gateways that you mentioned there.
Yeah. Okay.
So, yeah, all of the testing, the proof of concept is all around the link local MDNS.
Okay. Thank you.
Sure.
This is Stig. So I think it will be useful to get this presented or reviewed in some more application-oriented working groups or like apps area or something like that. I don't know if you have thought about that or one thing is, we want application people to be aware of this and potentially use it. And there could also be some input from people that maybe know DNS a bit better than we do here.
Okay. Do you think reaching out to maybe DNSSD is one? We've got another draft with them related to kind of multicast service discovery. And then what was the other working group you mentioned?
I think there is still something called apps area that is like application oriented things that don't have a particular working group.
Okay.
But let me look into that and see what we can find out.
Okay.
Yeah,
All
so
right.
what I'm suggesting is maybe next IETF, could try to present to some of those. But yeah, let's look into it offline.
Okay.
You want to move on to your next presentation?
Yeah, I think so. And if you want to run the screen for that would be
Okay.
fine. I don't have a demo. Okay, so I presented this idea, I think it was at IETF 118, and then it was called the null and void ports. Since then, kind of looking at it, decided to really focus that more on the use with multicast applications. The thought at the time was that maybe it could apply to unicast as well, and after thinking about it more, I don't really think that was going to work out. So again, focusing on this, we have a draft document out there, and there are the authors there. Next slide, please. So when thinking about this, you have to first maybe think about what is the transport protocol for. And so when you look at demultiplexing for unicast traffic, the idea here is with transport protocols, the port numbers are used to demultiplex the traffic that's destined to a different application, but on the same host. So as far as the protocol stack goes, the network layer or IP layer gets it to the host, and then once it's in the host, it may go to any number of applications, and the port number tells you which application to direct that to. Now, the traditional approach has been that each application protocol has been assigned a unique port from the registry. But as more and more applications were being developed, it became apparent that the port assignments, they're a scarce resource, and we should be more judicious in assigning those. So the other thing is that when you're running two copies of the same application, that the port assignment can struggle. So if you're trying to do two different FTP servers, you have to put one on the well-known port and another on a different one, and somehow communicate that to whoever is trying to contact it. Now, as far as improving this, a lot of improvements have been made for dynamic ports, allocating a dynamic port and advertising that using DNSSD. So that's really reduced the need for static port assignments. So the idea here is that we can do something somewhat similar with multicast. Next slide, please. So think about demultiplexing for multicast traffic. So multicast is more complicated. All of the hosts in the multicast group have to have the same port available. And furthermore, that has to kind of be pre-negotiated. You can't go to every host in the group and say, okay, well, give me an open port and negotiate that with everybody. It's got to be something that's known ahead of time. So doing that would be hard. So the traditional approach has been a static port assignment. But the thing with multicast applications is they don't actually need ports for multiplexing because the destination address already identifies the receiving application. So because of that, the destination port field is redundant. And furthermore, if a packet arrives on a host, there's been a lot of work to get it there, and so we should be using it. And if we don't need it, then we should do something to make sure that the host doesn't actually see it, like cut it off at the router, or at the switch, or so on. Next slide, please. So just a reminder, multicast addresses, we've got the fixed addresses. Those are allocated and maintained in the IONA registries. And then, as talked about earlier in the lessons learned document, there's a couple of different algorithms out there for dynamic assignment, the MADCAP, the ZeroConf one that we just talked about, and GAP. Next slide, please. So the proposed solution for demultiplexing the multicast or handling the multicast port issue is basically to reserve two ports and designate them as multicast application ports, 49, 150, and 151. So these are the last two ports of the user port range, and they're consecutive ports to support the RTP, RTCP protocols, which would be used for video stream distribution. Now, what's really nice about this is that we don't need to modify the network stacks of existing platforms in order to get this working. We can allocate these ports and start using them right away. Now, depending on the platform that the application runs on, there may be different requirements on this, but the idea here is that a conformant application could set the reuse adder or reuse port socket options to share that port with other applications. So again, the host stacks don't need to be updated, but it would be beneficial to do that. And then if you wanted to say, if you needed to modify the host stack, you would modify it so that those to act as if those ports are always shared. So you would never allow exclusive access to them. Torlis, you had a question. Do you want to ask that now or?
At the end, he said.
At the end, okay, thanks. Next slide, please. So this was a demo using SOCAT, and if you want to go back and look at that, that's in the IETF 118 PIM meeting, but I'll put it up here again. One thing, this demo ran on Linux, and the reuse adder socket option was not needed on this because it was the bind happened to the multicast address. Now, if you bind to the any address, then you do need to do reuse adder. But the problem with that is that you then receive the packets from every multicast address that comes in there. So you, again, I think with this, if you're developing an application on Linux, you would probably elect to bind to the multicast address to make sure you only got the packets that you're interested in. And if you, for some reason, needed to bind to the any address, then you might want to mix in maybe like a eBPF packet filter or something to make sure you're only getting the packets that you want there. Next slide. So I kind of made a note based off of the feedback that we got from Torless on the mailing list that these were two things to discuss. So specifically the reuse adder, reuse port. Torless had made a comment that we should go through and figure out what's actually needed on the different platforms, and that seems prudent. I think probably Linux, Mac OS, and Windows would be good to dive into further. And then also just general questions on how it would work with source-specific multicast. So I think Torless is at the mic, so go ahead, Torless.
Yeah, so the first thing I was wondering is whether we could get ports that are not today also used by Unicast, because if one of the ports is randomly used by another Unicast application that hadn't set the reuse adder, reuse port, then the multicast application would fail as if we didn't do all the work. So maybe there are explicit, two ports we can carve out. Not sure which working group would the best be for that but I think we would need to ask somebody like Eric Winke or so, UDP, transport. I think that's in the area. Then before even getting to source-specific multicast, I'm wondering where the filtering happens if we have two multicast applications, different multicast groups, same system, and now they're using the same port. Are these packets filtered at the kernel level, or would the library need to filter them, or would they not be filtered even? I remember just when, Steve Deering put that into the kernel, there was no such filtering, so the application had to filter everything, but I don't know where we stand today.
If you bind the socket to the group address, you should only receive that particular group, or bind to group and port.
No, I mean,
Yeah.
you do a UDP socket, you have the port number that you're binding to, so destination packets will only be that port number.
And the group.
And address. No, the address is not part of the bind.
The bind API uses a sock adder, which has an address and a port.
So to trigger IGMP or MLD, you need to put the destination multicast group address into a different API call than the bind. That's not the bind.
The bind doesn't do the join.
Right. Exactly. It doesn't do it. So you're right that if we let's say can make the kernel filtering of the destination address happen by also doing the bind for the destination address, that's one possible trick. All I'm saying is we should figure out that we feel safe that if we have run multiple applications, that no, wait a second, let me quickly finish, that we're not getting into let's say undesired filtering at the library layer, right? So punting packets unnecessarily to the user land and then filtering them there.
This is Dino. We don't have a problem. If you bind with a specific address and port, and only packets to that address will come to the application. If you bind with any in the port, then you'll get packets from any address. So it's up to the application programmer on how it happens. It all works for 2 decades now.
Mike, it might be worth going back one slide.
So I mean, just check out all these different multicast applications, right? So I think it's quite untypical to put the multicast address also into the bind. You typically only put that into the API call join multicast group. Yeah, that's where you typically put it in.
Well, I think there's differences on Windows and Linux too. My recollection with Windows is you actually have to bind to the interface address and then do the IP add membership to get that multicast.
Right. So wait a second. This
is for Linux up here.
For the IGMP join, I think you also have the interface address, right? So that it knows where the which interface the join goes to. So you don't need to have the interface address in the bind. So I think Dino is right. We can put the multicast destination address in the bind. I'm not sure that that's commonly done if that would be sufficient, right? In the end, just let us feel safe that we're not changing, that everything is filtered in the kernel that we don't want on our socket, right?
Yes, working fine.
David Lamparter. Applications have also used the bind address to determine the source address if they're also sending to the multicast group. The solution is obvious here, use 2 sockets. And also the problem is if you use SSM, you can only bind to the group address and not to the source. So I think that's still work to be done, which you mentioned in the presentation.
This is Dino. So I've written apps where I bind with any because I want to receive on that port when it's sent to my unicast address as well as multicast address that I have joined. But it's a separate step to add membership to each group that you want. So yes, you can accidentally, as an application programmer, not a kernel programmer, to screw up.
If it turns out that we feel safe, we can do everything with the same level of kernel stuff, just we may need to do more binding and maybe more sockets, that's at least good to know and put it in as a note, right? If we can't figure it out and there is going to be more punting, we may still like this, right? It may be not for all the applications. I'm just saying we should be aware of exactly the punting situation and what's the best we can do against it.
Yeah, so it's Stig here. So it's common even for unicast applications to bind to address and port. Like you want a different web server on different IP addresses or something like that. For multicast, I'm not quite sure if they in general bind to the group, but they can easily do it. At least the socket API supports this and the filtering.
This is Dino. Sometimes you bind on any because you don't know what your IP address is, or it keeps changing.
But yeah, this is a problem potentially for SSM that you can't share the same group address for multiple applications. You could do that today if you have different port numbers, but now you need to make sure that it really is unique for the application. I guess that's what was mentioned on the mailing list.
But what we don't know, right? So I mean, maybe the kernels actually are better in doing the filtering also based on what the joins are. David is saying no. You've looked in the kernel, right? So, but let's try to figure it out.
So, question I need to have.
The first point that Torlis made too is related to choosing a different port that was not likely to have any sort of unicast use for that. And I don't know that there is any port out there that does not have the potential to have a conflict. That's kind of what we're trying to do, is be the first ones.
But we, as you said, right? So we have allocated static ports for specific applications. And now we allocate another set of static ports for this, right? So, I mean, that space will work anyhow.
This is Dino. Related to your point, Nate, multicast quick might have this problem.
Sorry, that's my PC. It does
okay.
that every once in a while. Sorry.
It sounded like you're making coffee or something. So multicast quick might have this problem where the port number may be needed to be used for both unicast and multicast. So we have to look into that.
So it should be okay if someone is using this port for unicast at the same time, as long as they do reuse adder. But yeah, I'm not sure whether PIM is the right working group for this or not. It's kind of good to do it here because people know multicast, but at the same time, I wonder if int area or something could be a good place. We need to look into that.
I think if we can do the testing to get through our understanding what happens on the API level and what we recommend, we can still move it to another group if somebody thinks we don't want to finish it.
Yeah, so at least I would say happy to keep doing it here, but of course, yeah, before potentially adopting it, we should think about that. And just in general, where else in the IETF do you think we can get some good input?
Where would somebody do an update to UDP? I don't know, int area?
Stuart did present this on the Hot RFC meeting on Sunday, so maybe somebody will reach out from that. Okay, well, thanks everybody.
Thank you.
Good afternoon, everyone. I'm Sandy Zhang from ZTE. This presentation is for using multi-topology in PIM. I present this draft on behalf of our co-author, Benchong, Stig, Jeffrey, and Holman. Next, please. This is a brief introduction of this draft. We know that PIM usually uses the shortest path computed by the IGP to build the tree to multicast source from the receiver. And now there are some standards about supporting multi-topology and the flex algorithm in IGP, such as we know that OSPF can support multi-topology per RFC 4915, and the ISIS protocol can support multi-topology per RFC 5120. And both of OSPF and the ISIS can support flex algorithm per RFC 9350. So in this draft, we'd like to introduce the multi-topology and the flex algorithm to be used by PIM. Next, please. So this is an example. We know that in this figure, there's two multicast flows, and they have both the source R1, it is the first hop router, and they have the same receiver router, last hop router R6. So there's only one shortest path in the figure, such as R1, R2, R4, and R6. So all the both of the multicast flows will follow the same path to reach the receiver. But the bandwidth in the path is not enough for the two multicast flows. So there is packet loss. If we can use multi-topology or flex echo in this example, so two different paths can be used for the two different flows. So the multicast flow 1 can forward by R1, R2, R4, and R6. And the second multicast flow can follow the path from R1, R3, R5, and R6. So different passes can be provided, and there is no packet loss. Next, please. This is PIM extensions for achieve this goal. We know that we defined a new sub-TOV for the newest working group document, PFM, forwarding enhancements. Sorry, I haven't updated this presentation slides. This is also the working group documents. So in the draft, a new group source info TOV has defined, and it can carry multiple sub-TOVs. So we defined a new multi-topology sub-TOV under the group source info TOV. And also we defined a multi-topology join attribute for the path building from the receiver to the source. Next. Oh, sorry. That's all for the solution. It's easy for understand. If you have any questions or comments, welcome. Yeah.
Go ahead,
Seems like-
AC.
AC Lindum, sorry, I've been, I'm guilty of meat echo surfing and I'm not in the room. But, you know, the I in PIM stands for independent. And, just by the RPF can use any topology, or it can go to a route that's been computing using flex algorithm. Why would we need this?
Sorry, AC, your voice is low. Please repeat. Could you please repeat your question again? Yeah.
Can you hear me?
Yes, I can hear you, but your voice is low. Yeah.
How about now?
Better.
Okay. Yeah, what I was saying, the I in PIM is for independent. And that means it's independent. You don't need, I don't see why you need this, because you can have the RPF for PIM can use any topology, or it can use, or a route can be computed using flex algorithm. You don't really need extensions to PIM. I don't think you do. I don't know why you need them.
Oh, yes,
I
please.
haven't read the draft. Sorry, I haven't read the draft either.
Okay. Let me explain it again. Maybe I present it too fast. Please move the presentation, the slides to the front. Yes. So we can see this figure. As you see, different paths can be computed by multi-topology or flex ego by IGP. That's right. But we know that they can't be used by PIM directly because we always call the roots from IGP for the shortest path as the default topology. So if we'd like to use the specific multi-topology or flex ego for routing computation, we must know which topology or flex ego we should use for them. So we must advertise the information through PIM extensions to all the routers, including the receiver, to know the information and the receiver.
Yeah, I think we're in a circular argument here. I'll have to think about it more, but I don't think you do. I think you just do the RPF, and you can, the RPF can be to any one of the topologies, or it can be to the source can be computed using flex algorithms. So I don't think you need it. I'll have to read it and think about it a little bit more. But I don't. I'll I imagine you're going to get some of the other people in the queue have similar comments. Anyway, I'll give them a chance.
Yeah, allow me to jump the queue to try to answer AC's question, specifically about protocol independent part. My understanding is that in the old days we have DVMRP, where we use DVMRP to carry the routes that is used for RPF. And then the PIM comes along, which says protocol independent, meaning that we do not use PIM protocol to carry the RPF routes. I think that's the meaning of the protocol independent part. And now we, okay, then, right, you can use any protocol that, right, but it's, right. Okay. Yeah. So, but in the before PIM, is with the protocol itself will carry the RPF routes, like in the DNRP case, right? Right. Yeah. Okay. So I think that should answer AC's question about protocol independent part. And then with when in the presence of MT and flex algo, we do need when you do want your tree to follow a particular topology or particular flex algo, we do need this extension here to signal that information.
Yes.
Yeah, I guess only if you want different groups to use different topologies. That's the only reason. I guess that's what you're trying to solve, right?
Go ahead, David. Go.
Okay. Sorry. David Lamparter. So my PIM routing domain and my IGP routing domain is not necessarily the same size. For example, I could have 3 different larger networks running OSPF, ISIS, and 1 PIM domain across that. And those 3 IGP domains may use entirely different topology IDs, even if they're doing the same thing. How does that work here?
So if you can divide the topology or the network into different topology or use a different flex ego for it?
No, so I have 3 networks as far as unicast routing is concerned, but only 1 network as far as PIM is concerned, because interworking PIM is hard. So in my unicast setups, I use multi-topology, But those three networks have different setups for how they do things. So the ID from PIM would need to make sense for all three of them, or this breaks down. That's kind of my argument here.
So your PIM domain will across all the three domains, or just all three. We can use tunnel for it. Because you want to across some domain, right?
Okay, Stig, just not why this is not why I came up here, but just to comment on that. No, I agree that that would be a little bit hard to solve, but just one possibility. If the ID you specify is not the actual ID that you need in the IGP, but more like an abstract ID that says something like, I don't know, a certain, you want, I don't know, max bandwidth, whatever, and then you can translate that to whatever that is in the local IGP somehow. I don't know.
All right, Peter's been very patient. Go ahead, Peter.
Hey, hi guys, it's Peter from Cisco. Can you hear me, by the way?
Yes.
All right. So just one thing maybe you to think about. If you look at how the flex algo is defined, it is defined for a specific data planes. Today, it is defined for SRMPLS, SRv6, and IP algo prefixes. You do not say anything about any of these, and you have two choices. Either your sources and destinations need to be part of one of those planes, or you need to define a new data plane for this purpose, even though this is not a data plane as such, but it would have to be a new data plane from the flex algo perspective. So I didn't find anything about that in your draft, so just something to take into the account.
Yes, for the first hop router, he must know which topology or flex echo should be used for the multicast flows. And this can be done by administrator configuration or something else. Yeah.
My point was a bit different, but maybe we can discuss offline.
This is Dino. So I think the conversation is way more complex than it needs to be, and I will defend AC's point. So this has been implemented a long time ago with VRFs. So PIM could run over multiple VRFs, and it was a configuration item in the implementation on where PIM should join. And since source addresses were either in one or the other or translated with NATs, which is a more complicated case, you could decide which VRF you would use and consult the RIB, hence AC's comment about independent, that you don't need to signal this inside the protocol. Okay, now having said that, AC, what they want to do is they want to make it more dynamic, and they want this particular source on this diagram to tell the receiver what topology it's in, so therefore it knows what to join. And so it's basically providing it a VRF ID or a RIB ID or something, so it looks in that particular table to RPF, i.e. join along a certain path.
I'm gonna jump the queue too and say I understand now. I just don't know who'd want to manage a network with different source groups using different topologies and different flex algorithms and having it all run together. It seems
It's
a little
called
bit.
MVPN. It's already done. And yes, it's very complex.
But Stig here. So I know people that deploy networks that don't use separate VRFs like Dino said, but actually use multi-topology. And they basically need some kind of static config on the router to say that this specific group, I want to do RPF lookup in this topology, and some other group lookup in a different topology. So the benefit with this is that you don't need to do static config that matches up on every single router. You just need either the last sub router in the join case to have the config, or the first sub router if you use PFM.
Do you mean different?
So this could be put in ISIS, but this proposal is just presenting it as a flooding mechanism, right?
But
Yes, we didn't define any
networks.
IGP extension for it. We just use it. Yeah.
This is Dino. What you're trying to do is signal this information, and this signaling information is broadcasted. And when you broadcast in PIM, you use this new feature called PFM. You could have used a link state protocol to distribute it, like OSPF and ISIS, and that's just fine. You decided to use PIM.
Jeffrey from Juniper. To David's earlier comment about multiple IGP domains, I think the border routers will just have to translate for the FT identifier or FlexArgo identifier. And another general comment is that this is actually a mimic of the MLDP in the multi-topology and in the FlexArgo. And that draft is, I believe, it's in the IESC evaluation phase now. We're basically mimicking the same thing here. In the MLDP case, you need to find out how to reach your roots using different topology or different FlexArgo. Here, we're doing exactly the same thing. It's just that we're doing PIM. So that's another way to think about it.
David Lampard again. I think, Stig, you have indirectly answered a better way to do this by, like, the fact that this can previously be done with configuration by putting groups into, call it VRFs, call it whatever else. If that is what this mechanism communicates, I think it will have far fewer corner cases, weird issues, because you're not stuck to having this MTID being communicated between the PIM routers. It's coming from up into the PIM routers, and it's telling the PIM router what to do with a particular group, and then you can control what scope it's applied in, and you can deal with the IGP doing different things in different places, and you're far closer to what the existing implementations are doing. I'm not sure why this is moving away from having this be kind of configuration based into putting this into PIM itself. I don't think that is the correct direction for this.
Yes, you can do everything by configuration. Yes, right. But
I'm not suggesting this be done through configuration. I'm suggesting that a protocol that replaces the behavior of installing configuration and carries the same kind of information and settings into the routers. Like, you do want the protocol to carry all of this, whether this is an ISIS being flooded, or you can put it like candidate RP propagated to the PIN routers that way. That would also work. I'm just saying the transported setup for this should behave very similar to what we already have in divvying up groups into different VRFs, and these different VRFs do different things for their RPF. I agree you don't want to have that as a config everywhere, so fix the problem of distributing that config instead, I think.
So we have two motivations of this draft. One is not motivation, that's our goals. First one is that we must advertise all the information in the, we let every router, especially the last hop router, to know which path should he be joined, right? So that is from special multi-topology or FlexArgo. So the receiver must know. Of course, you can configure it. And the second one is that the multicast tree is building from the receiver to the source. So we must make the two steps consistency. Yeah.
I absolutely and strongly disagree with that. Two PIM routers do not care whether they both use the same ID for some RPF lookup. The thing that matters, yes, it needs to be consistent, but the MTID or anything like that is not the factor to determine that.
From this figure, you may know that if the receiver R6 doesn't know which topology or FlexArgo he should join, he may join every path in the draft figure, right? So the R6 will join the path, the shortest path configured by IGP if he doesn't know any topology or FlexArgo. So he will join he will send all the joins to R4 and R2 to R1. So they will use the only path for the multicast flow forwarding. So that's what we don't want it. Yeah. That's what we don't want it. So we must let the last hop receiver to know which group should I join. So we must get some information from the source or something else he must tell me which flows must belong to which topology of flex ego. So we must assign point. What's the sign be originated? So we can get it from the PFM advertisement. Or maybe you can use the MOSPF or something else to carry the information to spread in the network. That's all okay. But we prefer the PFM enhancement because it's provide an efficient way for the PIM information advertisement. So we can use it for the receiver to know which multi-topology or flex ego should be used for the multicast flow. Yeah.
I'll do more reading.
Okay, so you can see the group source info TOV. It's defined in the newest PFM forwarding enhancement working group document. It can carry the group and source information of the multicast flow. So we carry the special topology of flex echo information associated with the TLV. So we can let every router in the network to know the information. And so the consistency in the network can be guaranteed. Yeah.
Yeah, I mean, Humamed Bali from Nokia. I mean, let's look at that at 20,000 feet, right? This is a steering. There's a lot of providers out there that are trying to do IPTV over 5G networks or over even like regular networks as a carrier. And they just want to steer traffic for 4K, 1080p, or a standard via different flex algos, blue or red or default, right? So the only thing we have in our arsenal right now, and some of these guys, they don't want to do NG and VPN, right? Because let's be serious. When you do NG and VPN, there are issues right now. We are going to segment routing. I mean, LDP, RSVPTE, I don't want to say that, but I mean, nobody wants to bring in another protocol into the network when you're doing segment routing. So when it comes to SRv6 or when it comes to the segment routing, right now the story is beer or go to 3C or stay with PIM, right? PIM supports IPv6. So the question becomes, if I want to steer certain traffic, let's say I have a stock ticker that needs to get gold, needs to be blue, and then I have TV that needs to be bronze, and I want to steer this type of traffic, how do I need to steer it? This is, in my opinion, what this is trying to solve.
Yeah.
Just from 20,000 feet.
This is Dino. So the way PFM messages work, they start from a source and they go downstream. It appears to me that now the policy is made that by the source gets to select the topology. Why not have the receivers select the topology? Is this a conscious effort in the design to make the sources do it?
And at the previous version of this draft, we just wanted to use the receiver side to decide the topology of flex ego to join.
But it could, but it could be decided anywhere in the network, and it's just being distributed from the source, the server.
We thought it sorted this way in the previous version, but finally we found that it can't keep the consistency from the source to the receiver, because every routers in the figure must know which one is in the multi-topology, and the source, if the source can support the multi-topology as the receiver.
Yeah, I understand. I'm just worried that at the receiver side, at that part of the topology, those sets of nodes know the bandwidth and the resources that are available much better than maybe the source does. Because don't forget, the source is supporting whoever wants to join and receive, and there's could be varying bandwidth and different types of flows going on. So, I mean, I'm not making a statement one way or the other. I just want to know, was it a conscious effort to make it be done by the source?
Yeah, I can try to reply to that. I think this time, probably part of the disconnect is probably because of we put that info into the group source info TLV. What we really signal here is just what topology this tree should belong to. It really has nothing to do with the source itself. And I also want to reiterate that what we're doing here is really just a mimic of what MLDP multi-topology is doing. And that document is in the RFC editor's queue now. And so all the questions, arguments here for PIM, I think that if they are really valid, then we have a problem with MLTP as well. But I don't think we have a problem. It's really just we need to clear that disconnect. I think we should do a better job in clearing out the disconnect here. And yeah.
Go ahead, AC.
AC Lindum Labin. Okay, I understand now you want to do the multi-topologies per group source dynamically and somehow signal them. I can understand that. I understand, and you have some comments. But as far as the flex algorithm is concerned, within a topology, the lookup implies what algorithm. You really can't specify that in the multicast protocol. So I don't think you want flex algorithm under here. I think you only want the multiple topology. You can think about that. You don't want to specify the flex algorithm because you have a source. You do a lookup in a topology for a source. That topology that has already been installed by the flex algorithm corresponding to that source. You can't specify a different one via the multicast to look it up. So you don't want flex algorithm in here.
I think you thought is from the receiver side, so you can look up the RIB for the specific topology of FlexEagle, right?
Right.
So
but there's not a separate RIB per flex algorithm. There's one RIB, and you use a different algorithm. There's one RIB per topology. There's one RIB, and you use a flex algorithm to install the route corresponding to the source in it. You don't need flex algorithm. I mean, I don't think you need it here. You want me to send it to the list so it can be discussed?
Yeah, send to the list, and we need to move on.
Yeah.
Stig and Peter.
Right. That's what I was thinking. I think we're in a circular argument. Anyway.
Yeah. Go ahead, Stig.
Okay, yeah, I'll just try to say at a high level, we're trying to do steering. And the obvious option today is that you configure each router with whatever information you need for the steering, right? But what this proposes is that either you can configure at the receiving side, at the last stop router, what to use so that in the join message, you can signal that to upstream routers. So you don't have to configure your core routers with whatever information. The other option that the draft also discusses is to use PFM and do this from the source. But it allows for both. The idea is the same, that you can configure just an edge device, and that can communicate to whatever other devices that need this in the network, what to do. But yeah, there's some challenges here and things to look into that I mentioned. But yeah, at least you can do from either side. And one issue with the receivers is that what do you do if the receivers are configured differently? But whether you do it on the source or receiver side, yeah, you kind of need all the routers in between to agree on what that particular ID or whatever means, like what to do with that. Okay.
So I'd like to share some information from our implementation. When we implement this draft, we think that if we only configure in the receiver side, we can make the route from the such as R6 to R4 or R5. Then if the R5 can't support the topology or the FlexEagle, he will return the route in the default topology. So the route may be not be want to join. So the flow may be, the path may be built also, but that's what we want to be forwarded. So it's a problem. So if some implementation has a different result, you can let us know. So if we use the function defined in this chapter, every router will know the information, the group source information, and the associated topology and flex ego. So every router will know if he supports the topology or the flex ego. If he received the wrong join, received the wrong join, he will look up his table and find that, oh, well, I can't support this topology or this flex ego. So he will not forwarding the join to the next stop. So the multicast flow will not be forwarded by the wrong road. So that's the consistency we want to achieve. Yeah.
We'll talk about later. Hey,
Yeah.
go ahead, Peter.
After macro loop. After macro loop. Yeah.
Yeah, Peter.
Yeah, I just want a quick comment on Jeffrey's parallel with MLDP. In MLDP, the data plane was SRMPLS. In SRMPLS, Flex Algo can give you different paths per algo for the prefix because you have different labels associated with an algo. If you look at the SRv6, you cannot compute paths to the SRv6 locator in a different algos because the SRv6 locator itself has been assigned to an algo. So there's a big difference. Think about it.
Thank you, Sandy. We're good.
That's very great. Peter, please send your question to me directly. Thank you. That's very useful information. Yeah. Thank you.
Thank you. Dino.
This will be real quick, and it's not nearly as interesting as the last presentation. This is just document status. We, in the Lisp working group, we have in the charter, it says that we're going to take the multicast overlay working documents into standards track. So I just wanted to report on that. There's some of my own documents, but it's related to Lisp, so I'm going to skip over that. And we just have one comment about the gap thing, which we'll talk about at the end. So we have, I can see this better. We have 6831, which defines Lisp multicast on an overlay and how sources and senders on an overlay do multicast routing. And that was published as experimental in 2013. The working group decided to go ahead and standardize that. So we created a individual contribution called 6831 BIS. We're going to make that a working group document. So it'll be IETF Lisp 6831 BIS. And we also did that for 8378 as well. And I'll explain what those two things mean. So those two documents are going. Now we have this third document, which is an individual submission, but we want to turn this into experimental. And this allows us to map the overlay group to an underlay group. Very much like in the old days when we were running on SMDS and frame relay. How did you map the IP group address to a link layer group address? We have the same sort of problem here, but the underlay now is an IP network. So, I'll explain what we're going to do. But it turns out the way this works for the standards process to work is that this document points to both of those, but those two do not reference the group mapping because it's newer, and therefore we could standardize the two RFCs quicker. Next. So just a refresher on what 6831 does. This defines how you run an overlay multicast, an underlay native multicast, okay? And you basically use PIM to build the underlay distribution tree based on the joins and sources that are sending on the overlay, okay? That introduced this overlay state called EID, G, because the underlay network doesn't know about the source termed EID here. And what it would do, it would map it to, in the map cache, to an RLOC, G, where the RLOC is the IP address of the encapsulator. It turns out G is the same value here. So what we proposed in that draft is that the overlay group and the underlay group would be the same thing. That could present problems for providers. In 8378, we decided to have a signal-free way of doing multicast where we didn't use PIM, where we used the mapping system to define where receivers are, and we could do head-end replication if the RLOC set was either unicast or if it was multicast or a combination of both. It could send over both those types of environments. So basically, there's a signal-based one using an existing protocol called PIM, and one that uses the mapping system, and that's why we called it signal-free. Next. So what this list group mapping proposal does is we kind of formalized this S comma G definition with respect to overlays. And the overlay state would be SEID and GEID. And what that actually means is, since it's on the overlay, the underlay doesn't know about, in either unicast routing or multicast routing, doesn't know about SEID and GEID. So basically, the SEID is the source that's sending, and the GEID is what receivers join to. Underlay knows nothing about it, so we have to map. This is what's in the mapping system, so we have to map it to what's used on the underlay, and that's what the RLOCs are used for. So today we have something called SRLOC, URLOC, which means the SRLOC is the encapsulating router, and if it's sending the multicast to a unicast location because there's no native multicast, we call that a unicast RLOC. Otherwise, it could be sending it to an underlay multicast group called GRLOC. And then this spec basically says, how do you map from GEID to GRLOC? That's what this spec does. Next. And we have two solutions to that. One is hash-based, so there's no coordination. It's completely decentralized, where the GEID just uses a SHA-256 to produce the GRLOC. So all the receivers for the same GEID will hash the same GRLOC, and the coordination is algorithmic or automatic. But if you do that, that means it's the receivers and the applications that are deciding what groups to use. And an underlay provider may not want those group addresses to be used. So maybe if you want to put control in the underlays domain, you use the mapping system. And then the way it works is that you can put a distinguished name in the mapping system, something like this group 224.1111, where the 224.111 is the group EID that runs on the overlay. And it could map to 225.1111, and that's out of the address range of the underlay. So if you do that, then the ETRs just basically look up this mapping, and they could all coordinate to the same group to join on the underlay. I think that's it. We don't have to do this because it's list related.
Okay.
And you can go to thanks for all the fish.
Okay.
The reason I'm doing all this is because I'm planning on retiring really soon. And so we were trying to get a status of what the documents are. And so what came up in the list working group between Stig and I was, what are we going to do with the gap draft? So I don't know if you want to discuss that or make a comment on that. Or
yeah, so
for this working group.
Yeah, I'm on the draft, so I have to be careful. But we're planning to try to progress zero comp and gap quickly. Do we have to the end of the year or to the end of next year for you?
Let's see, 2025. I won't be here in 2026.
Okay, so we have a year and a half. We have a year.
Yeah,
and a half.
a year and a
Okay,
half.
yeah, we got plenty of
But
time.
that's not very much time in IETF time.
That's true. That's true. That's true.
So
Yeah, we will make sure these progress. Thank you. Tour list.
Okay, wanted to give an update on this BIS draft. Next slide. So as a reminder, 11.12, original definition of IP multicast, which later on we started to call ASM when we introduced SSM. And it also specifies IGMP version 1, which is where the fun begins. Namely, when just a few years ago you run into problems in networks with this surveillance cameras that explain that they only implemented IGMP version 1 because it's the only full internet standard, and obviously that's better than something like this crappy proposed standard IGMP v3. And so as part of our story, let's play the IETF game of actually making the things we want to sell full standards and not the old stuff. ASM still very useful, not for internet, but for other scopes.
But IGMP v1, we want to retire. So that's kind of, we need to cut the draft in half, throw half away, the IGMP v1. So that's basically what this effort is. Pretty much removed the Appendix A, which is IGMP version 1. And then, of course, also made the applicability statement that, we've got, what was our, RFC for SSM over the internet, so ASM for controlled networks. We also learned as part of the process here in the working group that obviously we need to try to figure out how we can keep the use of IGMP version 1 in existing IGMP v2 and v3 implementations unchanged. We don't want to change any code that runs and includes IGMP v1 if it's IGMP v2 and v3 implementations. So that was somewhat tricky to get all done right. Then I think some AD also stood up and said, let's capitalize the must and should. Luckily, that was actually well-written text, just, capitalization was required. Keep all the original text unchanged, so unless it was wrong and insufficient. And then we had two bonuses that we could put in there. First of all, the new naming, ASM, and mentioning SSM, and then also adding text for IPv6. We don't needed any of these normative specifications. They were all done later in some other RFCs, which are now all references here. But we didn't have any, RFC to point to say, here is the host stack for IPv6 multicast, and explains how that works, right? So that, there are these packets with IPv6 destination addresses. So that's basically all added. And so, yeah, that's basically what the work that we did. Next slide. So the chairs nicely asked for early IANA review. So just in the last few days, I added the IANA section with all these, 7 or 8 registries where 1112 was mentioned. So they're all going to go into pointing to 1112 bis now, the new one, except for the IGMP code points, which actually are referring to the message code points for IGMP version 1. So that's the only one going to stick to the old RFC 1112. I am asking IANA to put the references for 2236 and 3376 into the IGMP query, because each of these IGMP versions has strictly done a different version of that message format that only itself can distinguish. So hopefully by making that explicit in the registry will make it easier for readers to figure out that this is not only IGMP v1, but that this code point is used by v2 and v3. So the author here thinks the document is ready for working group last call, which hopefully in this working group triggers also more review then. I'm also trying to go to this strange new working group you haven't heard of, MBOD, and ask them as well if they might, maybe there are some people not here in the room right now, we'll see. So the document should very easily compare with IDDiff. So primarily Appendix A is gone, that was IGMP version 1, and instead there is a bunch of explanation, but in the main text, I think all the changes I was explaining should be very easily identified as diff. So hopefully we can get a little bit more reviews here during, hopefully working group last call.
So that's the request for us?
It is to the request, by requesting, yes.
Okay. All right, so thank you. We've got a good problem in this working group, which is really as of late, is that we've sent 7 or so drafts to Gunter's way. We've asked for publication, so he's pretty busy all of a sudden. And now we've got the gap in zero comp that we're trying to expedite a little bit. But yes, we will do that. We will do a working group last call, and we will just continue to pile on Gunter. Anything else? Because that's the last presentation.
Maybe just a quick question. I don't know how many have read this latest version, but if anyone has any concerns about last call, if they know any issues or things they want to address, great if they can let us know now or just email a mailing list shortly. All right. Okay. And yeah. Anything else?
All right, that's a wrap. Until Dublin.
All right, thanks everyone.
Thank you very much. Great discussion.
Thank you.
Yeah.